Hello everyone. TechGoodReads give you good reads about technology. Today I will talk about Bitcoin, and this content is from the Bitcoin and the cryptocurrency technologies. This is the book, and today I will talk about the history, problem, blockchain, distributed consensus, minting, why Bitcoin succeed. Those contents are related to the Bitcoin. In the trade history, there's some time that goods exchange directly, and we call this period is barter system. In the barter system, people exchange their goods. But for this mode, there's the problem. How to arrange a group of people who needs and wants align in the same place at the same time. So to improve that trade efficiency, some new mechanisms are introduced. The first mechanism is called a credit-based system. When Alice wants to buy goods from Bob, Alice just tells the bank, and the bank will send money to the Bob. Then Bob can give the goods to the Alice. Alice didn't spend something beforehand, but bank will deduct her money afterwards. So this means that Alice owns a credit to the bank. So in such a system, the debt that Alice owing to the bank is a risk. The benefits of such a system is there's no bootstrap needed. So such system can start quickly. Our credit card is also based on such a system, and at original time, giving card information is a security risk, especially when you buy something on an unknown website. So one way to mitigate such an issue is use intermediary. This is why PayPal is so popular in the previous years. Currently, if a merchant want to use the credit card, they must follow the standards. It's called PCI. It must ensure that customers' credit card are stored in a safe place. So with time goes on, such an issue already mitigated. Another issue for such a credit-based system is the bank can track your spending. Maybe it's not desired in most cases. Another system is called a cash-based system. For such a using cash, the problem is that it needs a bootstrap with initial allocation. If there's no cash at the beginning, so this system is hard to start. The benefits is that it is precise about the value. So we can evaluate each thing based on the money. And it also avoid any debt in such a system. Another benefit of the cash is that it has better anonymity. Because that bank cannot track if you use cash, how you use it. Also, cash can help users to enable their offline transactions. Both systems have their benefits. we already built up the credit system. Can we build cash in the digital world? So people think about this problem for about 20 years. Digital currency, the most problem facing is that double spending problem. Because it's for the digital documents or data, it's easy to copy one from the other. So if you use a digital thing to represent that currency, that digital currency can easily to be copied to another one and then used in two places. This is called a double spending problem. How can we solve such a problem? Maybe one solution is that we can use a server to do scanning and record keeping. In this way, we can see that if such a currency is already spent, then it should not be spent again. But using a server is violate that cache's benefits. It's not anonymous anymore, and banks or other authorities can track a customer how they use the money. The other side effect is that it must work online because it needs a connected server. The second solution is called DigiCash. This method is introduced in 1983. The core technology is called blind signature. This is a way to make sure that the cash is delivered by one person. For this solution, it's focused on detecting double spending instead of preventing it. Detecting is also very useful, just like a credit card spending on the air. On the plane, you can use your credit card to buy things. But at that time, your credit card cannot connect to the network. So in fact, it's not really communicated to the bank credit card company. But when the airline back to the ground, at that time, it will connect to your credit card company. If you spend on the air and you deny it, that credit card company will punish you and maybe give you a fine. This is also similar for the personal check. If you didn't have enough cash in your bank account, then the other people who hold your personal check to go to the bank to withdraw the money, and if there's no enough cash, your bank will have a fine to you. But for this solution, it needs server to verify, so it's not easy to be initialized. So it's failed because it's hard to persuade banks and merchants to adopt this methodology. Bitcoin solution is very brilliant and solve about issues. And the core technology is blockchain and distributed consensus. We will talk about later. Another problem for the digital cash is how to make a digital cash valuable. And also we can say how to generate a new cash. To make it valuable, we can compare to the gold and diamond. They are valuable things. And because they are not easy to produce, and people need much money to invest and then to get such materials. For the governments, they produce that cash. But government can produce as much as possible. How we trust it? Is it cash always available? For good governments, they should control such cash, how much they produce. So this is based on the government's credit. So how to make digital currency valuable? Possible solution is that maybe this is currency is backed with gold. So when we make one digital currency, we will have a similar amount of gold behind it. In this way, we can make sure that this currency is related to the gold and it has a real value. But this is also hard for your business to start. So Bitcoin solution use minting. This means that creating that Bitcoin, it requires to solve the computational puzzle. We will discuss these solutions later. We will talk about blockchain. To understand blockchain, we first need to understand hash function. Hash function is, we can say, is a mathematical computation. For any input, it can calculate a hash and output the hash sum. We can see that this in the right side of the picture. For a good hash function used in the Bitcoin or any digital currency, it has three characteristics. First is collision resistance. It means impossible to find x and y such that the hash of x equals hash of the y. But we should say that for the input, is true that some inputs may have the similar, have the same hash results. So they can have collision. But here, this collision resistance emphasizes that it's impossible to find x and y. We cannot deliberately find those input. The second feature is hiding. It means given hash output, not feasible to find input x. The third feature is called puzzle friendliness. This feature is used for the puzzle games, which is in the mining. It means the only way to solve a puzzle is to search the large space. There's no good results. No good algorithm can solve this faster. In the Bitcoin, hash pointer is a very important concept. It just extends the euro pointer. The definition is that a pointer to where data is stored together with the cryptographic hash of the value of this data at some fixed point in time. We can see the right side of the picture, except there's the pointer to the data. It also has the hash of the data. So this data structure is called hash pointer. It ensures the data cannot be modified. So we can define the blockchain. Blockchain is a linked list using the hash pointer. We can see the right side of the picture. Each data is linked, but it used the hash pointer, so this also ensures that the data cannot be modified. For the hash pointer, we can also think another usage that use it in the binary tree. This is called a Merkle tree. Using the Merkle tree, we can find a specific transaction more quickly than the linked list. So, except the blockchain, Merkle tree is also a very useful data structure. Another important concept introduced by blockchain is distributed consensus. To introduce it, we need to understand the digital signature. For the digital signature, it just like usually we signature on the notes or the documents, personal checks, is will be used to identify that you signed that documents. For the digital signature, it has two features. One is only sender can make your signature. The other is anyone can verify if the signature is valid. Let's see the right side of a picture. First, for the any data, we use hash algorithm to calculate the hash, and then we use private key to encrypt it. Then we get a signed message. For this signed message, it can be sent to the receiver to verify. Receiver can use the public key to decrypt it and to get the message hash and then verify the message hash if it's the same or not. This is how the digital signature works. In the Bitcoin, it build a distributed identity management. It means that each person, you don't need a central place to maintain all the identity. You don't need to register there. You just create identity on your local place, and you can use it. You can also destroy it, and in the future create another identity when you initiate another transaction. In the Bitcoin, it introduced the Bitcoin address concept. It's just a hash of the public key. We can see the right side of picture how to generate the Bitcoin address. First, we generate the public key, and then we use hash to calculate public key hash, and then we use base 58 check to encode, and then we get the Bitcoin address. For such an identity, it has a great anonymity and privacy. Of course, we may have a concern that two users use the same identity. There may be some collisions, but it has a very low possibilities. For the distributed identity system, is a decentralization system. Let's compare the centralization system and the decentralization. Telephone network is a good example for the centralization. The internet is an example for the decentralization. We can see that internet is more successful than the telephone network because it's more resilient. Bitcoin, the build concept is decentralization, but we cannot build the whole system only on decentralization. For the wallet that storing the Bitcoin, is also build centralization. So both system has their benefits. So we can often see all of them are merged and mixed used. Let's see how blockchain solves the double spending attack problem. First, it selects nodes randomly. Those nodes will be responsible to generate a new block and put the transactions there. So if it's a double spending, there are two blockchains are built. However, for the whole system, only one blockchain will be preserved. When one block gets more confirmation from the other nodes, then the following new blocks will build on top of it. So as time goes on, the longest chain will be used, and for that forked chain, it will be abandoned. This will ensure that no double spending attack can succeed. Of course, solving this problem depends on the node's honesty. For such a selected node, it must have more than 50% are honest to ensure this works. So we have another problem: how to make nodes honest? There are two solutions in the Bitcoin. One is block reward. Block reward means that for the whole system, if your node is honest, there's extra block will give you. This means that this is the only way to generate Bitcoin. In 2015, every 210,000 blocks created can get 25 Bitcoins. Another incentive is transaction fees. This is purely voluntary. So the sender, when want to do any transaction, it can also append some small transaction fees into it. So the node can get benefits from processing such a transaction. The third new technology is mining and proof of work. In our previous slides, we talked about we choose the random node to create a new block. But how to select such a random node? Node selection is in proportion to their computer power. This is how the Bitcoin choose those nodes. So how to evaluate those nodes' computation power? It uses the hash puzzles. For such a Bitcoin, it's also very interesting for that system's growth. It defines a rule that block reward is cut in half every 4 years. So this means there's a limitation for the total Bitcoin in the future. So the maximum is 21 million, and it will run out in 2140. Maybe this is the way that make a Bitcoin valuable, because in the future there's a limitation, and this means that Bitcoin has limited number. This is the one way to make Bitcoin valuable. For the digital currency history, it has about 20 years until the Bitcoin succeed. Why Bitcoin succeed instead of others? There's maybe following reasons help it. First is not to give up on a problem. Digital currency is a very hard problem, and many solutions are proposed, and it is about 20 years to solve. For the Bitcoin, it has innovations like blockchain, decentralized model, and those help solve the issues. The second is to be willing to compromise. For the Bitcoin, is practically useful, but less than perfect level of anonymity for users. That's not perfect, but it works. So it's succeed. The last reason maybe is successful numbers. For the Bitcoin, it built up a community, and the developers help contribute those society to develop it better, and also they use it. Because this community, they also persuade other merchants or maybe people to adopt it. More and more, this get succeed. If you want to know more about Bitcoin and those cryptocurrency, you can go back to see that book. I think it's very good to read. So here's some quiz you can do. I hope you can enjoy today's video. Thank you.